Hey, chemist and biochemist. In this video, what I'll be talking to you about is a D sugar versus an L sugar. Now, these sugars are going to look almost the exact same as one another, but there's going to be one major difference between them. So, with that in mind, I'd like to go ahead and draw an example of a D sugar. Now, the sugar that I always like to focus in on is glucose. I like to talk about glucose because, well, it's the one that's kind of the center to any sort of metabolism. So we've got one, two, three, four, five, and six carbons that make up my backbone. The most common way that you're going to see glucose is the D form of glucose. So what that's going to mean is that on carbon number one, we've got our carbonyl functional group. Carbon number two, we're going to have a hydroxide group on the right-hand side. Carbon number three is going to have a hydroxide group on the left-hand side. And carbon number four is going to have a hydroxide group on the right-hand side as well. Okay, so this right here is the most common form of glucose that you're going to find. And this truly is a couple of different things. It's an aldose, it's an aldohexose, it's a hexose, but the common name for it is D-glucose. Now that single letter right there all goes back to what is known as the penultimate carbon, or the second highest numbered carbon, or the carbon that is farthest from the carbonyl functional group. Okay. Now, this carbon right here, carbon number five, C5, I'll label it. Well, if I drew the same molecule, three, four, five, and six, but I put my hydroxide group on the left-hand side of the molecule for carbon number five. But I kept everything else the same. OH, OH, H, OH, and H. What's worth noting about these two is that, well, carbon number five, the hydroxide group is on the left-hand side as opposed to the right-hand side. Now, carbon number two, three, and four, those have hydroxide groups at the same positions, but what's important to notice about them is that relative to the penultimate carbon, all these hydroxide groups are in the opposite positions. So this right here is L, or sorry, this is an L sugar, but it is not L glucose. Now, if I wanted to draw L glucose, what I would have to do, or what I need to do, is put these hydroxide groups on the same side as my hydroxide group on my penultimate carbon. So what that means is I'm going to erase all these hydroxide groups and hydrogens that I've just drawn and redraw them. Carbon number four has a hydroxide group on the same side. Carbon number three has a hydroxide group on the opposite side. Carbon number two has a hydroxide group on the same side. There we go. What this molecule on the right-hand side of your screen, this is L-glucose. Because the hydroxide group on my penultimate carbon, in this case, carbon number five, my second highest numbered carbon, has a hydroxide group on the left-hand side. Or sorry, the hydroxide group is on the left-hand side. Now, two, three, and four, those hydroxide groups are positioned on the left, then the right, then the left. If to refer back to D-glucose, my hydroxide group on carbon number five is on the right-hand side. Carbon two, hydroxide is on the right. Three, hydroxide is on the left. Four, hydroxide is on the right. So it's important to think about the relative positioning of these hydroxide groups because that's what is going to dictate whether it is glucose or a totally different sugar. Now, that's kind of the crux of understanding a D sugar versus an L sugar, positioning of these hydroxide groups. More times than not, if you're talking about glucose, or if you see in a textbook or anywhere linear glucose reference, it might just be labeled as glucose. This D-glucose might just be presented as glucose. you might not see the detail D-glucose. The reason for that is because of the fact that D-glucose is the form that's metabolized by basically all known living organisms. L-glucose, by comparison, is extremely uncommon, and L-sugars in general are much less common. So, with that said, I hope you have a good one. I hope this helped your understanding of sugars.